Welcome back for lesson 9.2. We're still building on some concepts of hypothesis testing. And when we make a hypothesis, there's a couple different outcomes that could happen, and some of them are called errors and some of them are called a correct decision. So when we're testing a hypothesis, it's like saying that I was accused of stealing, okay? So the true outcome is what we always write up here. So the true outcome here is true or false. I stole, I did not steal. Okay, and then along here is the action. So do not reject H0 means that the court said I did not steal, I'm not guilty. And reject H0 is the court said I was guilty. Okay, so this is what the test says, or the court says. This is true real life outcome. Okay, so excuse me, if in real life I did not steal and the court said I was not guilty, then that's a correct outcome. This is good. If in real life I did not steal, but the court said I was guilty, that's called a type 1 error. And this is what we're going to call alpha. Okay, this is the percentage of when I truly did not steal, but they said I did. So I went to, let's say I went to jail and I actually didn't do anything wrong. Okay, over here, this outcome here is I actually did steal, but the court said I did not steal. That's not a good outcome either, right? So that means I didn't have to go to jail, but I really did cause, I really did convict a crime. I really did commit a crime. So this is bad. This is going to be called beta. We're really going to focus on this probability here, alpha though. And then the last outcome could be that I really did steal and they really did convict me. Okay, so that's a correct outcome. Those are all four described here as well. So each of the two errors with a particular probability. The Greek letters alpha and beta, like I said, mentioned here. So alpha is the probability of a type 1 error. It's the probability of rejecting the null hypotheses when the null hypothesis is true. So we can maybe make a note for this. This is a wrong conviction if you're thinking about in our legal system. That might help keep it straight. Beta is the probability of a type 2 error, the probability of not rejecting the null hypothesis when the null hypothesis is false. And you can think of this as a wrong acquittal. They let them go. Alpha and beta should be as small as possible because they are probabilities of errors. They are rarely zero. And they don't add to 1. So alpha plus beta does not equal 1. But when alpha goes down, beta does go up. They are affected inversely of each other, but not exactly complements, like P and Q when we talk about probability of success and failure in the other lessons. Okay. So let's look at a couple of examples. Example 1 says, suppose the null hypothesis H0 is the blood cultures contain no traces of pathogen X. State the type 1 and type 2 errors. Okay. So type 1 is H0 is false. So the test says there are pathogens when in reality there is not, because this is what we believe is true, is H0. So The type 1 is the test says there are pathogens, so we go against H0 when H0 is true. Okay, type 2. The test says there is not pathogens when in reality there are. H0 is false. These take a bit to wrap your head around. Example 2 says, suppose the null hypothesis H0 is a patient is not sick. State the type 1 and type 2 errors. Which type of error has a greater consequence, type 1 or type 2? Okay, so type 1 would be test says patient is sick, but in reality, they are not. And the type 2 would be test says they are not sick, but in reality, they are. And which has a greater consequence? It depends, because if illness is only, let's say it's only like strep throat, then saying that they're sick and giving them medicine when they don't really need it is not really a big deal. And then the type 2 would be saying that they're not sick with strep throat, but they really are. Neither of them is really too big of a deal. Now, if it were something like cancer, right? If they said they have cancer, but they really don't, that can kind of be bad too, because what if they do a mastectomy and they remove somebody's breast, but they don't need to? A type 2 would be the test says that they don't have cancer, but they really do. That would be, if it's cancer, I would say type 2 would be the worst. Has greater consequence, because that means they're going to say, oh, they don't have cancer and they don't do any treatment, and then the cancer progresses and they could ultimately die from that. So I would say if it's cancer, the type 2 error has the biggest consequence. It's a Boy Genetic Labs claims to be able to increase the likelihood that a pregnancy will result in a boy being born. Statisticians want to test the claim. Suppose that the null hypothesis H0 is it's a Boy Genetic Labs has no effect on gender outcome. Type 1 error is the test says the likelihood increased a boy but it really did not. And then type 2 is the test says it did not increase a boy, but it did. Which error has a greater consequence? Again, this one kind of depends, because if the parents really want a boy and it didn't really increase here, the type 1 error, they would be very bummed out if they said, oh, we did the test and it says it's going to be a boy and it wasn't. The type 2 error says, what if they really didn't want a boy and then it really did increase the likelihood, this test really did likelihood increase it, and they said it didn't. I think it just depends on the parents. That one I think is kind of a hard one to decide which one is a greater consequence. Okay, let's look at example 4. The red tide is a bloom of poison-producing algae, a few different species of a class of plankton called dinoflagellates. When the weather and water conditions cause these blooms, shellfish such as clams living in the area develop dangerous levels of a paralysis-inducing toxin. This happens down in Florida too, this red tide. If you're down by Fort Myers every year, a lot of times that gets affected. This is talking about in Massachusetts. The Division of Marine Fisheries monitors levels of the toxin in shellfish by regular sampling of shellfish along the coastline. If the mean level of toxin in clams exceeds 800 micrograms of toxin per kilogram of clam meat in any area, clam harvesting is banned there until the bloom is over and levels of toxin in clams subside. Describe both a type 1 and a type 2 error in this context and state which error has a greater consequence. Okay, so type 1 says, would be the test says clams exceed 800 micrograms, but in reality, they do not. Type 2 would be test says clams are fine, but in reality, they have too much toxin. So on this one, the error that has greater consequence is definitely the type 2, because the type 1 is they're just being overly cautious. They say that it has too much toxin, but it doesn't. And so they ban the harvesting. The fishermen probably lose some money, but at least you don't have to worry about people getting sick. Now, type 2 is they say, oh, the clams are fine. They go ahead and, harvest them, and then it causes sickness. This would be the bad one. So type 2 for sure on that one, on the red tide. Okay. So example 5 says, determine both type 1 and type 2 errors for the following scenario. Assume a null hypothesis, H0, that states the percentage of adults with job is at least 80%. Now remember, we said the H0 is always an equal to. So if it says at least for the H0, it means the HA is the opposite. It's less than 0.88. Okay. So it says, identify the type 1 and type 2 errors from these first statements. Not to reject the null hypothesis that the percentage of adults who have jobs is at least 88% when that percentage is actually less than 88%. So this would be a type 2 error. If you don't reject the null when the null is not true. Not to reject the null hypothesis that the percentage of adults who have jobs is at least 88% when the percentage is actually at least 88%. So that would be a correct statement. Do not reject, and it's not. C says reject the null hypothesis that the percentage of adults who have jobs is at least 88% when the percentage is actually at least 88%. So that would be a type 1, I'm sorry. You reject when H0 is true. And then D says reject the null hypothesis that the percentage of adults who have jobs is at least 88% when the percent is actually less than 88%. Reject the null hypothesis. Okay, so that would be a correct statement. Okay, so that concludes lesson 9.2 on type 1 and type 2 error. Catch me back for lesson 9.3.